My name is Dr. Fuller. I would like to introduce you to the mathematical world around you. One of the most essential things algebra allows us to do is solve problems where information is missing or unknown. In algebra, we often work with variables and equations. A variable is a letter or symbol that we use to represent a value that we do not know or one that changes. We get an equation when we join two math statements or expressions with an equal sign. The equal sign is critical to equations because it means that the two statements are exactly the same. In algebra, we do not think of this statement as 3 times 5 is or equals 15. In algebra, we think of this statement as 3 times 5 is the same as 15. This way of thinking means that we can manipulate the sides of an equation as long as we keep the two sides equal to each other. This is known as keeping the equation balanced. This idea of sameness in algebra leads to the algebraic properties of equality. Four of the properties state that when a mathematical operation is performed to one side of an equation, the exact same operation must be done to the other side to maintain balance or equality. However, I will begin with the reflexive property of equality, the basis for everything. The reflexive property of equality states that every quantity is equal to itself. The statement 8 equals 8 is an example of this. I think everyone agrees that this statement is true. 8 is the same as 8. If I add 5 to the left side of the equation, we get 13. If I leave the equation alone, you can see that the statement is no longer true because 13 is not the same as 8. But if the exact same thing is done to both sides of the equation, both sides are still equal, and the equation is still balanced. This process works for all four mathematical operations. The algebraic properties of equality allow us to do the basic manipulations of equations to solve them. These properties state that we can do the four basic math operations to equations and maintain balance. This knowledge that we can manipulate an equation leads to the idea of inverse operations. Inverse operations are opposite operations that undo the effects of a math operation. Let's look at some examples of inverse operations. Addition and subtraction are inverse operations because they undo each other. An example could be 5 plus 8 minus 8. Notice that if we add 8 to 5, we get 13. But when we subtract 8 again, we are back to our starting value of 5. If we have 10 and want to subtract 4, what is the inverse operation to undo subtract 4? The inverse operation to subtract 4 is add 4. 10 minus 4 is 6. Adding 4 returns us to the original 10 and is the undo operation for minus 4. Multiplication and division are another pair of inverse operations. Take the statement 5 times 8. To undo the multiplication by 8, use the undo operation division and divide by 8. 5 times 8 is 40, and 40 divided by 8 returns us to our original 5. Now let's see how the algebraic properties of equality are used with inverse operations to solve equations. The goal of solving any equation is to find the value of a variable. To do this, we perform math operations to get the variable alone on one side of the equal sign. We call this process isolating the variable. Suppose Claudia has some money. She says if you give her $5, she will have $12. How much money does she have? Since we do not know how much money Claudia has, we will represent it with a variable. I will use the letter M to represent money. Next, we know that if she had $5 more, meaning the plus 5, she would have $12, our result. This statement is the same as saying there is an amount that when we add 5 more, it is the same as 12. While you might have already guessed the answer, I will use algebra's rules to solve the problem. I begin by locating the variable I want to isolate. I do this first because I generally leave the variable alone and move the things attached. Next, I identify the elements that need to be detached from the variable, and I work to remove each. In our equation, plus 5 is attached to the variable m. I will use the inverse operation of addition and subtract 5 from both sides of the equation. We can combine the like terms of plus 5 and minus 5 on the left side. Simplifying the left side of the equation leaves the variable alone. Next, we simplify the right side. 12 minus 5 is 7. This leaves us with the statement m equals 7. Since I isolated the variable, I now have the solution. But before I can answer the problem, one step should always be performed. Some call this the check step, because we can check our solution to see if it is correct. This is an amazing feature of working with algebra. You can often check to see if your solution is correct. To perform the check step, I start with the original equation. M plus 5 equals 12. Next, substitute my possible solution for all copies of the variable. Since I think the answer is 7, I substitute it in for the variable m. Then, I simplify both the left and right sides of the equation. Finally, check to see if the final simplified statement makes sense. If the number on the left is the same as the number on the right, our solution is correct. In this case, we have 12 equals 12. This is a true statement. 12 is the same as 12. Therefore, our solution is correct. This means that Claudia has $7. If you end up with two values that are not the same during the check step, like 5 equals 3, it is a false statement. 5 is not the same as 3, so the solution is not correct. I always review the math in my check step first when this happens. Then, if necessary, I return to the original equation to find my mistake. Equations can have two unusual solutions as well. One will result in a check statement that is false, such as 5 equals 3. If all my work is correct, then we say the equation has no solution. Another possible outcome is that you end with a variable equal to itself, such as r equals r. R equal r is a true statement, but it is an unusual true statement. Pick a value to substitute in for the variable, such as 9. 9 equal 9 is true. Pick another value for r. How about -7? Now the equation is -7 equals -7. This too is true. In fact, any value will work in this type of equation. Since all answers work, we say the equation has all possible solutions or infinite solutions. This video is about single-step equations and inequalities. As you learn more about algebra, you will learn about more complex forms of equations. These equations are called single step equations because you perform one step to solve them. Claudia states that if she gives you half of her fries, she will have at least 15 left. How many fries does Claudia have? The statement that some amount divided by 2 gives at least 15 represents this situation. I will use the variable f to represent the number of fries Claudia has. So the equation becomes f over 2 is greater than or equal to 15. I begin by identifying the variable and the elements that need to be removed. Our one step will be to remove the division by 2. The inverse operation of dividing by 2 is multiplying by 2. Because of the multiplication property of equality, we must multiply both sides of the equation by the same value. Simplifying the left side of the equation isolates the variable f. Simplifying the right side of the equation gives 30. Our possible solution is f is greater than or equal to 30. Checking our possible solution means beginning with the original equation, substituting our solution for the variable, and simplifying. First, because this is an inequality, I like to check the possible options, the equal to part and the greater than part. I will check using f equal 30 and f equal 50 to see if both work. Since the left side of the equation of 30 divided by 2 simplifies to 15, the simplified equation for our first check step is 15 is greater than or equal to 15. This is a true statement, so the solution of f equal 30 works, and the equal part is correct. Next, 50 divided by 2 simplifies to 25. This simplified equation is 25 is greater than or equal to 15, which is also true. This means the greater than part works. We checked our possible solutions, so we know the answer is that Claudia has at least 30 fries. She should share. In my mathematical world, I have one little problem. Some friends are starting a small business and asked me for help. They decide to sell candles. There are many factors that make this a smart starting business for them, including that there is a fixed cost to make their product. The cost of the materials is $3.27 for a standard candle, and the group wants to sell this product for $5.99. The statement, cost plus markup equals price, represents this situation. What is their profit for each candle sold? They find a place that sells different types of candle jars at different rates. Each type has a different cost, so it is important to know which ones to buy. They do not want to spend more than $3.50 per candle to maximize their profits. If the jars come in a shipment of 40, what inequality represents the most they should pay per shipment? What is the most they should pay per shipment? The friends decide they need to have at least $161.73 in sales each day. The daily total sales is determined by multiplying the price of each candle by the number sold in a day. How many candles do they need to sell each day at $5.99 per candle? Candace and Kayla are discussing advertising ideas. Kayla says they should offer more than 100 scent and color combinations. This number is determined by multiplying the number of choices for smell by the number of colors available for the candle. The group decided there will be 15 cents available for the candle collection. What is the minimum number of colors they will need to offer so that there are over 100 color and scent combinations? Finally, the group wants to determine how much profit they will need to earn to meet some basic business requirements. A simplified idea is taking the month's sales and subtracting out the expenses. The remaining amount is the profit. If the group wants to earn at least $2,800 and has $1,566.71 in expenses in a month, what is the least amount of sales they can have? Take a look, and you will see a mathematical world around you filled with equations. We can use equations to represent many real world situations. And the principles of algebra allow us to solve all sorts of problems with equations. Equations can help us define the curvature of space or find lost civilizations. However, you may find the idea of working a problem backward while following a set of constraints appears in many places in the world around you.